Okay, good afternoon class. So today we're looking at the control test 1 of 2024 of our school. The paper was for 100 marks 2 hours. The question paper and memo can be found in the description box below. Alright, I'm sure I won't get through this lesson or this paper, but it will probably be over 2 lessons, okay? So we are told if cos of theta is equal to the square root of t, and theta is less than 90. Remember, if theta is less than 90, what does that mean? First quadrant. Everybody at once? First, nice. First quadrant. Express each of the following in terms of t. Right. So, if it's in the first quadrant, we draw it in the first quadrant. I don't have to draw it in this quadrant because why it is acute. The theta angle is there. What does cos stand for? Adjacent over hypotenuse. Okay. This is fixing the alignment. Okay, cos is adjacent over hypotenuse. So there's my angle. So the adjacent is going to be the square root of t, hypotenuse is going to be 1. So how do I get the opposite side? I apply Pythagoras, yes. For those of you hearing it for the first time, since it's the right angle triangle, there's one unknown side I need to calculate, which is my opposite. My opposite squared plus my adjacent squared, which is the square root of t, all squared is equal to 1 squared. So your opposite squared, or O squared, is equal to 1 minus the square root of t squared is t. You get over becomes minus. So what do I do now? Take the square root both sides. So this is going to be the square root of 1 minus t. Okay. Now, remember when I introduce square root, it will be plus and minus here, not so. But because this is on the positive part of your y-axis, it has to be positive square root 1 minus t. So what does tan then stand for? Tan is opposite, which is 1 minus t, over adjacent, which is the square root of t. Okay. 1.2. The question then says cos of theta minus 30. Girlfriend with a bag in front of her. Take the bag off. There we go. So, cos of theta minus 30. This should remind us of compound angles. Not so. So, the compound formula, and I gave you a formula sheet that you guys asked so nicely for, which you didn't use. Cos theta minus beta can be written as cos theta or cos alpha, cos beta plus sin alpha, sin beta. Okay. So what is your alpha angle here? Theta. So there goes theta, theta. And beta, of course, is your 30 degrees. 30, 30. So if I write that out, it's simply cos theta cos 30 plus sin theta sin 30. Now the 30 degrees, we know it's going to be a special angle. Special triangle, not so. So here on the side, I draw my special triangles. So to show the examiner, I know what I'm doing. Okay? So there's 30 is 1, 2, root 3. So cos is adjacent, cos of theta. So I must use this, adjacent over hypotenuse. There's the square root of t times cos of 30, adjacent over hypotenuse, which is the square root of 3 over 2. Plus, sine of theta is opposite over hypotenuse, so it's the square root of 1 minus 3 times cos is, sine is opposite over hypotenuse is 1 over 2. So this here can simply be written as the square root of 3t over 2, as you can see the denominators are the same, plus the square root of 1 minus. Okay, but you got full marks at this point already. I didn't allocate them off for this. Okay, some of you should be lucky I didn't, otherwise you lost another mark. Huh? So, cos of 2 theta. For cos of 2 theta, it can be 1 of 3. Not so. So we go cos 2 alpha can be written as 2 cos squared alpha minus 1, 1 minus 2 sine squared alpha, and cos squared alpha minus sine squared alpha. I could have used any one of them. Okay? I'm going to go with cos. So it's going to be 2 cos squared alpha minus 1. So what is cos? Cos adjacent of our hypotenuse. So it's 2 times the square root of t, which is cos alpha, squared minus 1. So what is the square root of t squared? T. So it's 2t minus 1. Okay. If you had gone with the other one, let's go with sine and see what we get in. So it's going to be 1 minus 2 sine squared theta. It's supposed to be theta here, not alpha. So it's going to be 1 minus 2 sine is opposite of a hypotenuse. So it's the square root of 1 minus t over 1 whole square. The square root cancel the square, so it's 1 minus 2 into 1 minus t. Get rid of the bracket, so it's 1 minus 2 plus 2t. Which gives me 2t minus 1. And if I had to choose this one here, you would have noted it would have been exactly the same. That's why I said you could have used any one of the three at that point. Okay. Any confusion so far? Or anything in here that I haven't taught you yet? Huh? No. Okay. You want to let me know, then? If there's something here I haven't taught you yet, then you must be given the marks. Okay? So collectively you must explain to me what I did. Okay? People, the next one saying simplify to a single term. You got cos squared into 180 plus x plus 10 x minus 180 times cos of 810 minus x times cos of x. So this is the reduction formula, not so. So we draw the cos diagram. There's all stations to clear. So this is 180 degrees. So it's going to be 180 degrees plus x. Which quadrant is that in? Third quadrant. Is cos positive or negative in this quadrant? Negative. But because of the square, not O, many of you write minus cos squared. Some people positive cos squared x. Normally we work with, if you're going to look at x, that's your angle x. You go minus 180 is in that quadrant. Not so. So that would be positive tan x. But say we don't work with negative angles. We have a positive outlook on life. So what we do is, instead of working with the negative, I add 360. Remember, if I add or subtract 360 to an angle, I don't change anything. So 360 minus 180 is 180. So in other words, that is tan 180 plus x. Still it goes into the second quadrant. Tan is positive, so it's positive tan x times. Now, if I subtract 360 from 810, 360, just get the calculator with me. So 810 degrees minus 360 minus 360 gives me 90. So in other words, this reads 90 minus x. Not so. So that 90 minus x takes you to quadrant 1. Is cos positive and negative in quadrant 1? Positive, but changes to sine x. And that cos x, you don't check, you just write it down. Positive. You don't leave it out now because you got no, nothing's going to happen to cos, so you might leave it out. No. Okay. So what we're going to do now is we're going to change tan to sine. Everybody got that mark. That's going to be sine x over cos x times sine x over 1 times cos x over 1. So what happens now? Cos cancels. So it gives you cos squared x plus sine x times sine x, sine squared x. So cos x plus sine x is cos squared x plus sine squared x is 1. Ayat is sitting in amazement, see there? With a hand in front of her mouth. She couldn't believe it so easy. Right? Yes. People 3.1.3. We went over this. I told you we're going to test you on it. And you people still miss it up. Huh? When I came here, I thought, no, it's a prank. No? Honestly, like. Okay, so let's just leave the shade for a while. So now we got cos of alpha minus beta. Given cos of alpha minus beta is equal to cos of alpha, cos of beta plus sine of alpha, sine of beta. However, they ask you to derive the formula sine alpha plus beta equals sine alpha cos beta plus cos alpha. People, if you're going to start off with this, you're going to lose everything. Okay? You can't start off with that. Okay? So we must start off with what is given. And we must end off with what we need to prove. Okay? So, cos alpha minus beta can be written. How can this be written if we want a sine here? Can be written as sine 90 minus alpha minus beta. No, not cos. If we say sine 90 minus theta, it becomes cos of theta. So sine 90 minus alpha minus beta can be written as cos of alpha minus beta. You see that? So, get rid of the brackets, so it's going to be sine. No, I made a mistake. No? I'm supposed to start with sine. First thing you have to say sine of alpha plus beta. Can be written as what? Cos. Yes, I understand what you're saying. Cos 90 minus alpha plus beta. Thank you. Now I can use this formula. First get rid of these brackets. Becomes cos 90 minus alpha minus beta. Now this is now my alpha and this minus beta. Okay. So that's now going to give us alpha is now 90 minus alpha. So it becomes cos 90 minus alpha times cos of beta plus sine 90 minus alpha times sine of beta. 90 minus takes you to which quadrant? Quadrant 1. It's cos positive and negative. Positive. Changes to sine alpha times cos beta. 90 minus takes you to quadrant 1. Sine changes to cos alpha sine beta. And there we got exactly what they wanted you to prove there for 4 marks. Can you believe it? It's like a giveaway. After I put this in the paper, I thought now the children will start liking me from here. No, not a chance. People, 1.4. If sine of 23 is equal to P, if sine of 23 is equal to P, the question says, with the aid of a sketch, determine the value of cos 44. So this at 1.1 is very similar, not so. So what we do is we say, okay, sine is what? Sine is opposite over hypotenuse. I can put it in the first quadrant or I can just draw it without. So this is going to be 23 degrees there. Sine is opposite, which is p, hypotenuse is 1. Apply Pythagoras, I get 1 minus p squared. What's the size of this angle here? So it's going to be 90 minus 23. Or 180 minus 90 minus 23. It's going to give you 67. But they want cos of 44. So I'm going to get cos of 44. There's one of probably many more than 2 ways. But if I say 90, remember, we're trying to link 44 with one of these angles here. So if I say 90 minus 44, gives me 46, which is double 23. You see that? Let's say you didn't know that. We can also say, but hang on, 67 minus 23 is what? 44. Not so. So you say cos 67 minus 23. And lo and behold, this cos of alpha minus beta, we spoke about it already. Compound angle. So we do the compound expansion first before we do anything else. So it becomes cos 67 cos 23 plus sine 67 sine 23. So cos is adjacent of hypotenuse, which is the square root of 1 minus p squared times p over 1, which is p, plus sine of 67 is adjacent of opposite of hypotenuse, is the root of 1 minus p squared times sine of 23 is p. Further notice, they're the same. So it's going to be 2p root 1 minus p squared. Okay. Is that a beautiful sum? People 1.5. This sum we have done more than once. This is one of the examples also from the section of one. Okay? So we can either work left hand side, right hand side. If I go on that side, I'm going to use the conjugate pair, or the right hand side, and left hand side I'm going to rather go with. People 1 can be written as cos squared x plus sine squared x. Not so, sine squared x plus. This will be cos squared x plus sine squared x. Not so, that is what your 1 is. However, your minus 2 sine 2x can be written as 2 sine x cos x. And this is all over. That can be written as 1 of 3. Can either be written as 2 cos squared x minus 1, 1 minus 2 sine squared x, or cos squared x minus sine squared x. Which one of the 3 you think we're going to use here? Third one. Why? Because we resembles that there the most. Not so. So it becomes cos squared x minus sine squared x. So let's go. What you should be seeing here, if I replace cos with the x, says x squared minus, and sine with a y, then what do we see? We see a trinomial. Not so. And this can be factorized. It's actually a perfect square trinomial. So it's going to be x minus y squared, or x minus y times x minus y. If I transfer that into this information, what would it read now? Cos x minus sine x squared, all squared, or cos x minus sine x. And this is all over. What can happen here? What the factorization here? Dots, yes, difference between two squares. So that would simply be cos x plus sine x and cos x minus sine x. So what can happen now? It cancels. Cos x minus sine x cancels cos x minus sine x, which gives you cos x minus sine x over cos x plus sine x. So hang on. The same as the right hand side. Exactly the same as the right hand side. Okay? Then the next question says, determine the value of x, or the values of x, where x is an element of 180 to 360, for which the identity will be undefined. When will something be undefined or invalid? It's when the denominator is equal to 0. So in other words, it's where cos 2x is equal to 0 or sin x equals negative cos x. So sin x plus cos x equal to 0. So in other words, tan x is equal to negative 1. So it's at these 2 points. Okay. Let's go with the first one. So for the cos, it's the cos graph. Why? Because it's 1 minus 1 is 0. Take it to the graph. This is 2 cos x. What does that 2 affect? Nice. Period, yes. So what's the normal period on the cos graph? 360. Because of this 2, the period is now 180. So if that's 180, that's 90, leaving this with 45 and 135. Not so? So in general terms, this is going to be x is equal to 45 plus k times, this is solution repeating every 90 degrees. Otherwise, you could have written 45 plus k times 180. No. (45 plus k times 360). Why? Because that's a cos graph. Or did I say 45 now? So the b was 2x is equal to the normal cos graph is at 90. So it's 90 plus k times 360. Or 2x is equal to 270 plus k times 360, which is now x is equal to 45 plus k times 180, or x is equal to 135 plus k times 180. You could have written it like that, or in one like this. Okay? If I look on this side here, the tan graph, where's tan negative 1? At negative 45. That's also on your graph. But negative 45 will be picked up if k is equal to minus 1 here. So I don't need to go and write this branch down. But looking at the restricted domain here, x is only an element of 180 to 360. So what do? I say x is an element of, and I start listing. Okay. So what do? I put the 0 where I see k. If I put the 0 where I see k, what do I get? 45. Is that inside or outside? Outside, yes. Outside. Now if I put 1 in here, what do I then get? 135. Inside or outside? Outside, yes. Now what if I put 2 in there? So it's now going to read 45 plus 2 times 90. So that's 180 plus 45. I don't get 12. 2 to 5. Inside or outside? Inside. So that's 2 to 5. Now I put 3 in. 315. Inside or outside? Inside. Add another 45. No, for another 90, sorry. 405. Sorry? Outside. 145. 135 is also outside. So let's just put a line through it. So the marks is 1, 2. With one more. Just change it accordingly. Okay, there I would have also lost my packet of paper. Wouldn't have gotten full marks. Right, but you guys understand? They must made it up in the bonus question. Let's see if we get it. But no mistake. Do 1.6. We are given cos of x plus 2, cos of x over 2. Write the given expansion in the form of a cos squared over x and into y is equal to a into cos squared x over 2 plus b cos x over 2 plus c. People, what does that remind us of? Trinomial, yes. So I'm going to get the trinomial out of that. She says she doesn't know. But what relationship exists between x over 2 and x? Is x not twice x over 2? Which means now to say that y is equal to cos 2 x over 2 plus 2 cos x over 2. Is that not the case? Make sense? Yes. So where does this fit in? Come on, sir. How can you ask us that? We know it's to do with this here on top. This one here. Cos 2 alpha. What is alpha now in this case? Sorry? X over 2. So which one of the three am I going to go with? The one dealing with cos y, because we've got the cos x over 2. So in other words, it's going to be 2 cos squared x over 2 minus 1. You see that, people? Lisa Khaled, are you crying, my girl? Huh? You cry for real, I'll give you another one more. Extra. Alright, so let's go. We're going to get 2 cos squared x over 2 minus 1 plus 2 cos x over 2. But isn't the format that they wanted? No. So it will be 2 cos squared x over 2 plus 2 cos x over 2 minus 1. And there it is now in the trinomial format. Okay. Verstaan julle? Yeah. Alright, now it says find the minimum value of the given function and state the corresponding value or values of x for which x is an element inclusive of 0, 2, 3, 60 exclusive. If I had to write this in inequality format, it will be x is greater or equal to 0 but less than 360. Okay, you'll see there doesn't even make a difference, the values doesn't even come close to this. But anyway, people, this is a trinomial to us. If they're talking about maximum or minimum, what do we do? Quadratic, yes. If you are given a quadratic and they're talking about maximum or minimum, what do? We get our best sleep ever, yes? In this room? Wake up. Is she okay? Is she still among the living? Yeah? You sleeping? Oh, you're not sleeping. My eyes lying to me. People, trinomial. She makes yes. What is that? Factorize. No. When we talk about maximum or minimum. Oh my God. We complete the square. Don't you complete the square?
That's what she said.
Oh, is that what you said? Okay. It didn't sound like it. But okay. So now we're going to complete the square. Okay. So for those of you who don't see it, you should be seeing 2x squared plus 2x minus 1. That's what you should be seeing. So what do we do first? We take out a common factor of 2. Okay. So it's 2 into cos squared x over 2 plus cos x over 2 minus a half. For those of you who are confused, I would have written it on the side. I take out 2 as a common factor first. Okay. Now what do? We must add a number to complete the square with. Not so. And how do I get that number? Is b of b times half squared. And what's your b value here? What's your b value? 1. So 1 times half. What is 1 times half, people? Half, yes. And what is a half squared? A quarter. For those of you who can't see it, it should be 2 into x squared plus x plus a number minus the same number minus half. The number we said here is going to be 1 times a half, which is a half, and it must be squared. So quarter. So what is this now to us? Perfect square trinomial. So it's 2 into cos x plus a half squared. Now minus a quarter minus a half is minus 3/4, I think. No? We have done the same here. There's a perfect square trinomial. So it's 2 into x plus a half squared minus 3/4. Okay, what do I do from here? Get rid of the bracket. So it's going to be 2 into x plus a half squared minus 3/2. Exactly on the same here. Sorry? Cos x over 2. Thank you. So I got y is equal to 2 into cos x over 2 plus half squared minus 3/2. Have I answered the question? What's the question? Find the minimum value. So what's the minimum value? Negative 3/2. Okay, good afternoon class. So we're just continuing with this paper that we started with yesterday, as we knew we were going to run out of time. So hopefully we'll finish it up today. So at this point, we're at 1.6.2. We completed the square when it came to this expression here. Okay, and on the side we have done it in terms of variables only without your trig ratios. Okay, so the question says find the minimum value of the given function and state the corresponding value of values of x, where x is from 0 to 360 degrees. Okay, so what we do is we say, okay, this graph has a, since it's positive, the graph is smiling, it has a minimum value of negative 3/2. And occurs at cos of x over 2 equals negative half. So we need to calculate the value for which x satisfies this condition, and also considering it's within that given domain. So we say then my reference x over 2 equal to r cos of 30 of a half, which is 60 degrees. So the question that should come to mind, which quadrant is cos negative? Which quadrant cos negative in quadrant 2 and 3? So how do we get into quadrant 2? So 180 minus is x over 2 is equal to 180 minus 60 plus k times 360. But because we know it's from 0 to 360, it's not going to affect us really. Okay. So we say 180 minus 60 is 120. And 120 times 2 is 240 degrees. Okay. And there was 120, okay. So it's 240. Or, as you can see, 240 is within that given domain. Or on the other hand, it's going to be x over 2 equals 180 plus 60. Then we're going to go plus k times 360 is again going to be outside, other than with k0. So that is 240. So it's x over 2 is equal to 240 times 2 is going to be 480 degrees. But because that is outside the given domain, I've omitted that, and that is the solution I was looking for. Okay? So any confusion there? Alright. People, otherwise what you could have also done was, you could have looked at this here and said, okay, if x is an element of 0 to 360, because I got x over 2, I divide it by 2, so should this be as well. So divide that by 2 is 0 to 180, which then I would have picked up, x over 2 would have been 120, which means to say it would have only been this one, and of course, that which is 240 is of course outside the given domain. This is another way of looking at it. Okay? Let's look at question 2. Now we're going to our exciting part. Ne? We did a lot of these things. Not so? Well, I did a lot of it. Okay? Put this in front. So here we are told that in the diagram, I'm just going to make this a bit smaller so we can keep both in focus. Okay. So in the diagram, triangle ABC is drawn. ABC is drawn with G on AC. So that it will be such that AG over GC. So AG over GC is 1:3. I can't put a 1 and a 3 here. Hey! Why are you making so much noise? You don't make the noise here, man. Right, so what do we have? 1K. And 3K. You see that, people? If you, that kind of dollar, want to use a AU or X, you may do so. Then H is the midpoint of BC. So if this is X, and then that is also X. Not so? So I call that A and A. Alright. I'm not going to use K again. Okay. We will associate all these lengths on the side with K. Everything to do with that side A, and so on. Okay. Then we are told that F is the point on BC, so that F is the point of BC, so that GF is parallel to EA. People, with these lines be parallel, we know many things. We know that GC over GA is equal to FC over EF. Also BE over EF is equal to BH over HG, and so on and so on and so on. Okay. Then the question says, write down with reason. Okay, so that is 2.1. So there's a 2.2 as well. Okay. Write down with reason EF over FC. So when I go look at EF over FC is equal to AG over GC. Not so. So that is fairly straightforward. So EF over FC is going to is going to be AG over GC. Why? Because of the proportionality theorem, with FG being parallel to A, which is also equal to, it's 1K over 3K, which is 1 over 3. So since I got A's there, so I'm going to say this is going to be 1B and 3B. Then what is EC? 4B if needed. Okay. Then the next question says, hence. So what does hence mean? It means the same as usual previous calculations answer, not so. Hence, determine the area of triangle ABE over the area of triangle AEC. So if I investigate and say, okay, ABE is that triangle, not so. And AEC is of course that triangle. So what does those two triangles have in common? A common height. As you can see, this shares a apex there. Apex. So that's your perpendicular. Sharing a perpendicular. If it was this triangle and that triangle, what are they then sharing? A common angle. They're not going to use a sine rule in this case. Can you see that, people? But because I'm sharing no common angle there, so what am I going to use? The perpendicular. So how do you calculate the area of a triangle? So it's half base, which is BE, times perpendicular over a half base, which is EC, times the perpendicular. But that now cancels, not so. But BE I don't have. However, EC I have to be 4B. So what must still be calculated? BE. Can you see that, people? So now I go and calculate BE. Okay? Let's take this out here. I don't want the diagram to be too cluttered. So what I'm going to do now is I'm going to say to calculate BE. I'm going to calculate BE. We see that BE is lying in this triangle here. Not so. Of course, lying in that big triangle as well. But what I notice is those lines are parallel. Can you see that? So we have this being parallel and that being equal. So BE has to be equal to EF. Why? Converse of the midpoint here. Can you see that, people? But when did we do midpoint theorem? In grade 10. So I think I must do a little exercise on the midpoint theorem again. Just to enhance your, or to refresh your memory. So we did a lot of midpoint theorem in grade 10. You guys remember? Oh, you don't remember. Okay. But what you need to say at this point is firstly that BH is equal to HG given. Also, HE is parallel to GF. Why? Given. So I state what is given. So therefore BE is equal to EF, which is equal to B. Why? And we see it is going to be the converse of the midpoint theorem. That also get the marking B there. Okay. So what that now I can answer the question. So take them away. So BE, what is BE? BE over EC. And what is EC? 4B. Which is the same as quarter. 1/4. Right, you guys understand? Okay, that's how easy that was. Let's go to the next question. Here we are told that in triangle ACD, we are told that AB is equal to BC. AB is equal to BC. GE is 15. AF is equal to FE, which is equal to ED. So, without going anywhere else, what can be concluded here? These lengths are equal. So what can we say? BF parallel to CE. Why? Midpoint theorem. So these lines are now parallel and these lengths are equal. What can be concluded now? That BG is equal to GD. Why? Midpoint theorem, converse of midpoint theorem. Just look here again. When I was talking about this triangle, what did I say? Midpoint theorem. Why? Because those lengths are equal. However, when those lengths were equal, I could have concluded these lines were parallel. However, when I spoke about this triangle now, what do you notice? That is equal and I use parallel lines. So this is equal. Why? Converse of midpoint theorem. Okay? Again, I will do an exercise dealing with this again. Okay? But I won't blame you guys. It's because we only did it in grade 10 and I expected you to know. And we did it in grade 11, but let's throw a blind eye on that as well. Sorry? Of course not. Okay. Alright, so let's go. So we're saying that is equal. That was equal there. Alright. So now the question says, and this was 15 here. Now the question says calculate the length of GC. For 5 marks, it's not going to go straight and calculate GC. No? So what can be calculated here? What can be calculated first? If this is 15, if I can prove that is 30, that came very close. And we know that that is twice the sum length. So let's go. We know that, firstly, AB is equal to BC. And AF is equal to FE, which is equal to ED. Why? Given. I'm only going to use that part. That's just the one part I have to get in the next step. So with that we can conclude now that BF is equal to, BF is parallel to CE. Why? Midpoint theorem. So now I can write this parallel lines in. Now, in the other triangle, for those of you who can't follow, in triangle BFD. In that triangle, this was in triangle ABD. No, ACE, sorry. ACE. Okay, so in the other triangle we can now say that FE is equal to ED. I'm going to write it again. Okay, that was given. And we know that BF is parallel to GC. Why? Proven. So therefore, BF is equal to twice GE. Why? Why is that twice this? Converse of midpoint theorem. So in other words, that's going to be 2 times 15, which is 30 centimeters whatever. Okay. Now coming back to this triangle here. We know that that length is double CE's length, not so. So you can say now that BF twice BF is equal to CE. Why? Yeah, you can either now say converse of midpoint theorem because you got the lines that is parallel, or midpoint theorem. Okay, and because BF is 30, so CE is 60, not so. So CE is 60 centimeters, and therefore CG is equal to, say, if this whole length is 60 and that is 15, then what is that? 45 centimeters. Okay? Yes, Michael?
So where did you get the marks here?
The marks definitely you're going to get the mark here. Okay? You're going to get the mark for stating this. It's parallel. Then this here, this is statement and the reason. Eh? Then you get the mark for getting the 30 out. Mark there, statement and the reason. I think for one of these I gave you a mark for stating the reason for one of those. Now just check there, where was the mark, Stephen? You just give the memo, let me see. So one was this midpoint theorem, I gave you 1 mark here. For 30, I gave you a mark this statement and this is your reason here. Then one statement and reason, this was statement reason mark. It was 1, 2, 3, 4. Yeah, 5. Okay, thank you. Answers your question. Why do I owe you a mark? No. If you're not midpoint, I would give it to you. Didn't I? Alright, you must get that one. Okay. So now you got the A. No? We're bringing you closer. Okay. Then if you're not midpoint, you should get the mark. People, this question here was worth 5 marks. It's normally 6 or 7. But I needed 1 mark. I was 1 mark over, so I just took it away from you. Huh? I can't just give you 101 mark. Come on now. Right. So, people, the link to this proof is in the diagram box below. Okay, I'm not going to do that proof now. Right, so let's go with 3.2. People in question 3.2, I think is a bit too big. I feel like I'm moving slow. No? Right. In O is the center of the circle with diameter 5 centimeters. People's whole length is 5. Okay. CPQ is a tangent to the circle at P. If there's a tangent, tan goes here. Not so. And of course that with that and all of those Mickey Mouse things. And AQ is a tangent at A. So this angle here is equal to that angle there. But we have 2 tangents meeting at point Q. So what does that mean? Many things. Yes. It means to say that AQ is equal to PQ. Why? Tangent from common point. Okay. So what's that? I'm going to get upset with you. Alright. So OQ and PQ are drawn. AOBC is a straight line with BC equals 4 centimeters. The question says, prove that CBP, so where do I start? In triangle CBP and triangle CPA. So if you look at the triangles in question, is CBP and CAP. What can we say? The angle C is common and this angle is equal to that angle. Not so? So that's enough to prove similarity. So let's say, we can say that angle C is a common angle. That's the first one. Second one, BPC is equal to angle CAP or PAC. Why? This is tan fourth theorem. So of course the third one has to be equal. So PBC has to be equal to APC. Why? It's the third angle of triangle. So therefore, triangle CBP is similar to triangle CPA. Why? Angle, angle, angle. Okay, with 3 marks. How do you mark this here? Sometimes it's 4 marks, no? If it's 4 marks, then there's a mark given for that as well. Okay. But there's 1, 2, 3 marks. Statement and reason. Okay. So always write it in just in case it comes. Okay. Which word the mark? Right, next question. Now we are told to calculate the length of CP. See this here? It's a length you must calculate. Right, as we know, what is going to follow a similarity question? It is a ratio question or a distance question. So let's go with number 2. We know that CB over CP is equal to BP over PA equals CP over CA. Why? Because triangle CBP is similar to triangle CPA. Okay. What's the length of CB? 4. CB is 4. CP unknown equals BP unknown, PA unknown equals CP unknown over AC 9. As you can see from there to there is 9. Okay. People, that is what I need. Not so. So 4 times 9 is 36 is equal to CP times CP, CP squared. So CP works out to be 6 centimeters. Can it be negative? No, we're talking about length. So CP is 6 centimeters. Okay. So we answered that question. As you can see, I need this space here, so I'm going to take this off. Now the question says, calculate the length of AQ, which is this length. Okay, so what I did was I let AQ be X, just to make it easier for me to see. Okay, it's an X. But AQ, but we know that AQ equals PQ, which is equal to X. Not so. So what do we see now? We know this is your radius or diameter tangent, so that has to be 90 degrees. Not so? So CAQ is equal to 90 degrees. Why? Radius perpendicular to tangent. Or diameter perpendicular to tangent. Sorry? The reason for the first one is tangent from common point. Thank you. See, I would have lost the mark there. No purple for me. Alright, so now the Pythagorean theorem. What's the length of the hypotenuse here? X plus 6. So x plus 6 squared equals this length, which is 9 squared plus x squared. Reason? Pythagoras with angle CAQ equal 90 degrees. Okay. So it's x squared plus that times 2. 12x plus 6 squared, which is 36 equal to 81 plus x squared. That cancels. So 12x equal to what? 81 minus 36. 9 minus 4 is 5, 45. No. It will be nice if you guys check. What's 81 minus 36? 45. Divided by 12 both sides. So x works out to be 3.75. Which means to say this is 3.75 and that is 3.75 if needed. Okay. Fairly simple, no? Once you see somebody else do it. Then they ask you to prove that BP, you must now prove that BP is parallel to Q. People, if those lines were parallel, then what could we have concluded? That AB over BC is equal to? No. These lines are parallel. So AB over BC is equal to PQ over BC. Why? Proportionality theorem. Not so. Now, in order for us to prove that these lines are parallel, I prove that the proportionality theorem works. It exists there. So it can be applied. So let's go. You don't have to say this, but I'm going to write the intra-angle. This is now 3.2.4. Intra-angle COQ in this triangle. We know that OB is equal to, what's the length of OB? 2.5. Where are we getting that from? The radius. Not so. Diameter is half your radius. So, what we do is we say, okay, what is OB over BC? So, OB is 2.5 divided by BC, which is 4. over 4 gives us 5 over 8. Yes? 5 over 8. So if I can prove that QP over PC is also 5 over 8, I've done the job. Okay? But what do you notice? I didn't start off by saying OB over BC is equal to QP over... I don't start like that. Okay? So I'm proving is actually the case. So QP is 3.75 divided by 6. And 3.75 over 6, lower and behold is 5 over 8. Okay. So what do I say now? What do I notice now? They're the same. So I say since OB over BC is equal to QP over PC, which is equal to 5 over 8. Since that is the case, therefore BP has to be parallel to OP. Why? Because of the converse of the proportionality theorem. Because of the converse of the proportionality theorem. Okay? People, you guys can do this. I believe you can do this. People, this here, what formula do you have to prove here? The sum to arithmetic progressions or arithmetic series. Not so. People, that link can be found in the description box below. Okay. People, we're considering the sequence 3, 1, 3, 2, 3, 4, 3, 8. What's the next number? 3, 16. How do I get that? As you can see here, this forms a sequence on its own, not so? And then of course, that is also a different pattern on its own. So there's 2 in one sequence here. How would you identify that normally? If there's a lot of numbers, more than usual, then you know now they're doing something fishy here. No? So 4.2.2, calculate the sum of the first three. Say, hang on, if there's a 2 in one sequence, half of it is going to come on the 3's, and half is going to come on the other sequence. So we got 3, 3, 3, 3. And how many 3s do we have? Half of 20. Not oh, that is like the highlight. There are 10 3s, not so. And then on the other sequence, we have 1, 2, 4. That's not 4, I don't know what that is. 4, 8, 16. How many of them do you have? Also 10. So the sum of 20 terms is going to be 10 of the 3s, 3 10s. So do I have to say 3 plus 3 plus? No. 10 times 3 plus 10 from the sequence. But what sequence is this? Geometric progression. Whoops. Geometric progression. GP. So what's the formula for GP? Sn is equal to A or n minus 1 over r minus 1. Not so. So what's your A value for the sequence? 1 into. Or, how do I move from one term to the next? Times by 2. How many terms are there? 10. Minus 1 over 2 minus 1. You put that in a calculator. It's 3 times 10 plus 1 into 2 to the 10 minus 1 over 2 minus 1. 1053. $1,050. Okay. Any confusion there? No? Not yet? This is not where the problems are, no? Must still come. Right. 4.3. Calculate n if the sum of the general term of which is 4 plus 2 open brackets k plus 1 equals 140, starting at 4 ending at n. People, what does this denote? What does this mean? General term. So that's the n. This here is n. So the sum of the sequence is 140. You all see that, people? So when we start by working out our first 3 terms. So we start with subbing 4e, where we see k. So we're going to get 4 plus 2 into 4 plus 1. Not so. So that's going to give you 5 times 2 is 10. It's going to give you 40. Go with the next one. 4 plus 2 into 5 plus 1. What's 5 plus 1? Nice. 6 times 2? 12 plus 4? 16. The next one. 4 plus 2 into 6 plus 1. What's 6 plus 1? 7 times 2? 14 plus 4? 18. And that is the first 3 terms of the sequence. People, how do we calculate the number of terms? The number of terms is going to be your end point. Number of terms is going to be your end point minus the starting point plus 1. What's your end point here? N minus starting point 4 plus 1, which is n minus 3. So there's n minus 3 terms in this sequence. Not so. So let's go. Because we know what Sn is, do we have the last term? Do we have the last term? Make so? No. We don't have the value of the last term. So which formula must we use? N over 2 into 2a plus n minus 1. If I add my last term, Sn is equal to n over 2 into a plus r. So what is Sn? 140 equals n over 2. What is n now? N minus 3. Okay. People, if you use n to be n, there's no problem. At the end, you want to subtract 3 from the sequence. Okay. So it's n minus 3 over 2 into 2. What's my a value? 14. Plus, your n value is n minus 1. So the n minus 3 minus 1. That minus 1 is that minus 1. Times your d value of 2. As you can see, I'm adding 2 all the time. Alright, so I cross multiply, get rid of this 2. I'm going to get, of course, 280 equals n minus 3. Of course, I must put that in a bracket because I'm multiplying now. I'm dropping the fraction. into 2 times 14 is 28 plus 2n minus 8. Right, so that is to give you 280 equals n minus 3, 2n plus 3. Can I say n minus 3 is equal to 280n? No, it must be 0. Not so. Multiply out, so I get 280 is equal to 2n squared. That is 20n minus 6n. What's 20 minus 6? 14. And then negative 16. So 0 is equal to 2n squared plus 14n minus 340. Is that correct? So, of course, one of two ways. I can either use the quadratic formula or this calculator. I'm sure nobody's going to find the roots there. No? So it's going to be 2, 14, negative 3, 40. Gives me n is equal to 10. Did I make a mistake here? Negative 17. So how many terms are there? So therefore it's 10 terms. Didn't I write 7 somewhere? 10. Okay, I think some of you got 7. Somebody got 7. Huh? You got 7. Yeah, that the wrong answer stick to my head. How did you get 7? You used n here, no? Yeah. And everything else you got right. Did you put the 140 in? And this here? So you will have n minus 1 here. Then you have to add 3 at the end. Then you would have gotten this answer of 10. Can you see? So how many marks did you lose? Huh? Look, I think it's fair. It's not fair. How much? You can't tell me when you must get full marks for some that you made a mistake in. Sorry? The 140. But you must make this mistake here. And you made it in the sum easier. Not so? Yes, you made the sum easier. People consider the sequence. Determine the value of the values of x for which the sequence converges. People, when will the sequence converge? If and only if r is greater than negative 1 but less than 1, provided r is not equal to 0. There's 2 marks, so I didn't penalize if you didn't use this properly. Okay? So how do you work out r? It's term 2 over term 1. So it's 9 into x plus 3 cubed over 27 into x plus 3 squared greater than 1, negative 1 but less than 1. So what do I do here? Simplify. 9 and 9 once, 27 3 times, that cancels completely with 2 over 3 on top there. I get negative 1, x plus 3 and 1. As of course a 2 in 1 here, that goes either way. Negative 1 minus 3 is negative 4, x and, yes? Over 3. Right, my mistake. This boss. Yeah, pay for video now, no? Yeah? Yeah, okay. That makes it. Yeah. There's no scared, no? Right, people, I lost this here. This is over 3. Not so. I multiply by 3. So I get negative 3. X plus 3 is less than. So what do I do now? That 3 goes both ways. Not so. So we got x minus 6 and 0. Is that correct? So as long as x is greater than negative 6 but less than 0, as long as x is not equal to negative 3. Any value between negative 6 and 0, the series will then converge. Okay, you guys understand? Then the next question says, okay, we need to take this out here. Now it says, Determine the sum to infinity of the sequence x is equal to negative 1. People, is negative 1 between negative 6 and 0? Makes sense? Yes. Nice. So what do I do? Wherever I say x, I put a negative 1. So it's 27 into negative 1 plus 3 squared. Then 9, negative 1 plus 3 cubed. 3 into negative 1 plus 3 to the 4 and so on. Okay. Oh, there it is the extra number. Oh, that's why I didn't put the extra one. But anyway. So I got negative 1 plus 3 is 2. 2 squared is 4. 4 times 27, 108. This 2 squared is 4 times 9. No, cube. 64. 64 times 9. Anybody? 576. Is that correct? Huh? No. This is 2 cubed is 8. Okay. 512. Huh? Just wait, we first did 27 into negative 1 plus 3 squared 108, yes. So that is cubed. And there's a 9 here. 72. Oh, did I put 3? 60. Where did I get 64 from? I don't know. Alright. So I got 3 into negative 1. People, the question paper memo can be found in the description box below. Okay. So that is going to give you 48. Determine the sum to infinity. What's the sum to infinity formula? A over 1 minus r. The A value is 108. Over 1 minus r is going to be, of course, 72 over 108. Or 48 over 72. So that is 108 over 1 minus 72 over 108. Which is 324. Or you could have worked this out. I think that is, okay, I'm not going to guess. And say it's 3 over, something over 2 over 3. Okay. The next one, the giveaway. Given that Sn is equal to 3n squared plus 2, calculate S61. So how do I do that? We guys here end up with the 61. So it's 3 times 61 squared plus 2. Not going to use my head. Plus 2 is your 11165. So 11,165. Then they ask you to work out T62. So we know that Tn is equal to Sn minus 1. So for T62 is going to be S62 minus S61. I say, hang on. I know what S61 is. I've worked it out already. So S62 needs to be worked out. So it's 3 into 62 squared plus 2 minus 11165. So I say 3 into 3 times 62 squared plus 2 minus, that goes answer calculated, it's 369. Okay. Any confusion there? Anything I haven't taught you yet? Say. I haven't taught you anything by the looks of it. What did you say? Did I teach you all of these things? Yeah. Oh. People were at the music school. Musical instrument, right? We are told that a simple musical instrument has many strings. Attached as shown in the diagram alongside. The difference between the length of the adjacent strings is constant. The shortest string is 30 centimeters and the longest string is 50 centimeters. People, what we notice here? We have the first and the or the first and the last. Okay. The sum of the lengths of the string is 1240. Alright? Find the number of strings. So, we know this is Sn. So it can either be GP or AP. Not so. So we read again. We are told here the difference between the lengths of the J. The difference. So this is a arithmetic. Okay, otherwise we will speak about the common ratio. So now for arithmetic we have two formulas. The one that we just used, n over 2 into 2a plus n minus 1 d, or Sn is equal to n over 2 into a plus l. Why a plus l? I got the last and the first, or the first and the last, vice versa. You see that people? 1240 is equal to n over 2 into a is 50 plus l, which is 30. So that's 80. Divided by 2 is 40. So therefore n is equal to, I think it's going to be 31. The 1240 divided by 40 is 31. So what does that mean, people? There are 31 strings. Okay. Well, what the musical instrument is this? Who does music? Maja, talk to us. Guitar. Okay, a harp, yeah. The way it looks like that. But okay. To me, many things looks different. Okay, to what it looks like through the eyes. People, 3 sets of twins. You got Anna and Adam, Ben and Brenda, Charles and Conrad are sitting on a bench. Okay. In how many ways can they sit randomly seated on the bench? So how many seats would we have? 6. Okay. They will have their own seats, no? For those of you who know want them. Okay. So how many options do you have for the first case? Then 5, 4, 3, 2, 1, which is 6 factorial. Or you can write what's the 6 factorial? 720. No? You all agree with that? See any confusion? Let's look at the next question. Now they want to know how many ways can they be seated if each person must sit next to their twin. So how many seats are we going to have again? 6. 1, 2, 3, 4, 5, 6. So if Anna and Adam is to sit together, we bind them. Ben and Brenda, we bind them. And Conrad and Charles, we bind them. How many ways can the first set of twins be seated? 2 factorial. The second case, 2 factorial. The third case, 2 factorial. But will it be in that order? No. Give me 4 minutes. No? So in other words, this can be rearranged in how many ways? 3 factorial ways. So it's 2 times 2 times 2 times 3 factorial. 2 factorial is 2. Okay. So the answer is 48. It's 48 ways that can happen. Okay. The last question for 5.1 we are asked, what's the probability if they are seated randomly that Brenda and Anna will sit together? Or Anne, whatever. So if you bind Brenda and Anne, so they will take up 2 seats, not so. How many ways can they be seated? 2 factorial ways. Not so. But this can happen. You count this as 1 bit. 1, 2, 3, 4, 5. Times 5 factorial. But they ask us for the probability. So that's the total number of outcomes, is 6 factorial. So the probability is going to be the number of favorable outcomes, which is the condition. 2 factorial times 5 factorial over the possible outcomes, which is 6 factorial. It's going to be 2 factorial times 5 factorial over 6 factorial. So it's 1 out of 3 chance they will sit next to each other. Okay. The next question. How many 5-letter word arrangements can be made from the letters of the alphabet if the middle letter must be a vowel? People, what are vowels? A, E, I, O, U. There are 5 vowels. So how many options do I have for the middle that they speak about? 1. Okay. How do I know it's only that one? Because they speak about the letter. The letters may be repeated. So how many options do I have here? 26. Can I use that vowels again? Yes. So it's simply going to be 5 times 26 to the exponent. 5 times 26 to the exponent 4 gives us 2284 880. So that's going to be 2,284,880. People, the bonus question in the graph below. The shaded region is bounded by the graph of y is equal to 4x, which is this here. X is equal to a, which is that line there, and the x-axis, which is that line there. The question says, calculate the area of the shaded region. The area of the shaded region. So, area of a triangle is going to be half base times perpendicular. So, it's going to be half. My base, of course, is 8. My perpendicular height, of course, is going to be, now what is your x value? Of course, a. If I substitute a into here, I get my y, which is 4. So the height of this piece is 4. So half times 4 is 2. 8 times a, of course, is 2. Okay. People, enjoy the rest of your day. Good afternoon, class. Yes.